This video is meant for Mrs. Rose's AB Calculus class, and in it we're going to discuss the second free response question from the Derivatives AP Packet. Alright, when you have multiple variables, x and y's, you need to use implicit differentiation when you're finding the derivative. And therefore, when you take the derivative of your variables other than the one that's in the denominator dx, you need to have like a dy dx. So, the first part we need to use product rule. We're going to have 1 times y squared plus x times 2y dy dx minus, and then I suggest you use brackets, 3x squared times y plus x cubed times dy dx, close brackets, and then the derivative of 6 is 0. Then I'm going to distribute my negative, and then I'm going to move the terms that don't have a dy dx to the right hand side, and I'm going to take the terms that have dy dx and I'm going to factor out a dy dx. The final step is going to be dividing the left and right hand side by the parentheses. Dy dx is going to equal that. This is worth 3 points total. You get -1 for every error that you make, whether it's arithmetic or whatever. You can't get negative points though, so the least amount of points you can get is 0. For part B, finding all the points where the tangent line is horizontal means that we need a slope of 0. In order to get a slope of 0, we need to set the numerator equal to 0. So I'm going to take the numerator and set that equal to 0. That is worth a point. If I factor out a y, you can have y equal to 0 or 3x squared minus y equals 0, and so 3x squared equals y. And then we're going to test when y equals 0. So, if you plug in 0 into your original equation all the way up at the top, we have y squared and y over here. So we have x times y squared minus x cubed times y equals 0. But when you plug in 0, you're going to get 0 on the left and 6 on the right, and that doesn't work. You get 1 point for realizing that y equals 0 doesn't work. Then for the third part, we're going to test when y equals 3x squared. So, again, we're going to use that original equation. We're going to have x times 3x squared squared minus x cubed times 3x squared equals 6. And if you square this and distribute the x, we're going to get 9x to the 5th. And when you multiply these, you're going to get 3x to the 5th equals 6. 6x to the 5th equals 6. X to the 5th equals 1. X equals 1. And when you plug in 1 into your y equals equation, you're going to get y equals 3. So the tangent line is horizontal at 1, 3. That is worth a point. For all points where the tangent line is vertical, it's a similar reasoning. The tangent line is vertical when dy dx is undefined or when the denominator of dy dx equals 0. So we're going to set the denominator of our derivative equal to 0, factor out an x, and then x can equal 0 or 2y minus x squared can equal 0, and solve for y. First, we're going to test when x is 0, and again, we're using the original, so x times y squared minus x cubed times y equals 6. But we run into the same problem we had before when y equaled 0. When x equals 0, 0 somehow doesn't equal x, and so x equals 0 does not work, and that's worth a point. When you test y equals x squared over 2, and you plug everything in, we're going to get x to the 5th over 4 minus x to the 5th over 2 equals 6. And I multiplied everything by 4, and then combined like terms, divided by -1, took the 5th root, and there's my x value. To get the y value, I just plug it into the x squared over 2. So there is a vertical tangent line at the 5th root of -24, comma, fifth root of negative 24 squared over 2. And that's worth the last point out of 9.